Okay, let's begin by looking at a few examples of one-step equations. And when I say one step, I mean it's only going to take us one thing to manipulate to solve this equation. The first one we have says a plus 12 equals 100. Now remember, this a right here, all that really means is some unknown number that we don't know. We're trying to figure out what number could that be that makes this a true statement. What we want to look at to begin with is that operation. How is 12 connected or attached to that a? And in this case, it's with addition. To figure out that missing number, we always want to do the opposite operation. So in this case, the opposite of addition would be subtraction. We're going to subtract 12 from that side, which would leave us with 0. But anytime we do something to one side of the equation, we must also do it to the other. So we're going to subtract 12 from this side also. Now 12 plus negative 12 equals 0. So I'm left with just an a on that side. But on the other side, I have 100 minus 12, which is 88. And now I figured out that missing number. Notice, if I were to put 88 back into here instead of a, I would have 88 plus 12, and that equals 100. That's what we mean by a true statement. Now, as we move on down the list, we've got some other one-step equations. They all look different, but they all only take one operation to figure out. In this case, 5 is attached to the y through subtraction. So let's do the opposite of that, which is addition, but we have to do it to both sides. This becomes 0, but on the other side we have 20 plus 5, which is 25. And once again, if I were to take 25 and put it back here instead of y, I would get a statement that is true. 25 minus 5 equals 20. Now, as we move on down the list, it gets a little more complicated just because the operation changes, but not because it takes more steps. In the problem we have right here, notice there's nothing written between the 4 and the x, which means they are multiplied. It could also be shown this way, and that's sometimes how you'll see it. But the point remains, if they are attached through multiplication, we want to do the opposite, which is divide by whatever is attached to that unknown number. We have to do it to both sides. Negative 4 divided by negative 4, we say that cancels out, but really what it makes is 1 times x. Negative 4 over negative 4 is 1. So we have 1x. On the other side, we get 32 divided by negative 4, which gives us negative 8. X equals negative 8. That's our unknown number. As we look at our very last one, this generally confuses a lot of people because of that right there. They go, oh, fractions. Oh no, can't do a fraction. Well, let's remember, every fraction is just a division problem. And if it's a division problem, it means we can undo it with multiplication. So I'm going to multiply both sides by negative 2. Now what that does is it makes these two things cancel out, kind of like we saw right up there. It means it becomes a 1. We have a 1c. On the other side, this becomes negative 14 times negative 2, and remember, a negative times a negative really makes a positive, which is 28. So our answer is C equals 28. Now, every equation you see from here on out will look a lot like one of these 4. As you scroll back through there, these pieces will show up in every equation we do. The problem is there may be more than one of them to deal with at a time, and we'll get into that in the next video.